What is Cevas' theorem? The theorem claims that, given any triangle ABC as shown on the whiteboard, with point M being the interior point, segments through M from either the point A, B or C to the opposite lengths of the triangle are Cevians. Whilst Cevas' theorem says that the product of the ratios of the pairs of segments formed on each side of the triangle by the point M equal 1, where the ratios are taken in the same orientation on each side. Also, if the ratio of any three Cevians equals 1, then these three are concurrent. Now, let's move on to the proof. Given the triangle ABC that you can see in the video, I need to prove that BF, this line, AE, this line, and CD are concurrent. Now, let's consider how we could split the triangle. Upon splitting the triangle, you can see that tan A equals BF over AF, which is the same as CD over DA. This is because the extension of BF is a perpendicular bisector of AC, forming a right-angled triangle ABF, which is the same for CD on AB. Therefore, from that, we discover that AF equals BF over tan A and DA equals CD over tan A. We can also tell using the same method as before that tan B equals AE over EB, which is the same as CD over BD. This is due to the perpendicular bisector method, making these two triangles shown on the whiteboard. From that, we can determine that EB equals AE over tan B and BD equals CD over tan B. For the final angle C, using the perpendicular bisector method to find right-angled triangles, you can see that tan C equals AE over CE, or BF over FC. This gives us that CE equals AE over tan C and FC equals BF over tan C. We will then substitute the answers we have worked out into the formula AF over FC times CE over EB times BD over DA equals 1. For our workings, we are aware that AF equals BF over tan A and FC equals BF over tan C. We also know that CE equals AE over tan C, whilst ED equals AE over tan B. Finally, we know that BD equals CD over tan B, and DA equals CD over tan A. That all equals 1. Cancellation, we are left with AF over FC, CE over ED, and BD over DA equals 1. Therefore, we have proven that the altitudes of this triangle are concurrent.